So one last problem with being able to identify the center, radius, domain, and range and sketching the graph of a circle, we have this x squared plus y squared minus 6y minus 16. And the first thing that we should probably do is write this in the form of the standard form of the circle, remembering that it's going to be x minus h squared plus y minus k squared equals r squared, which our circle is going to have center h comma k, radius r. So one thing that we remember is that we can complete the square to be able to put this into the standard form. This one's a little different than the previous because there was no singular x or no x term that was raised to the first power. And so here's the way I'm going to do this. I'm going to rewrite this as x squared and just leave it like that. Right? And then now what I'm going to do is I'm going to write the y square term in the y terms as y squared minus 6y, and then I'm going to leave a blank, and I'm also going to add 16 to both sides. Now recall from the previous video that to be able to complete the square, we're going to take the half of the middle term, or the middle coefficient, and then we're going to square it. So that's going to be negative 3 squared, which is going to be equal to 9. So I'm going to add 9 to the left-hand side. Whenever I do the left-hand side, I better do to the right-hand side. So a couple ways to write this at this point. We can certainly write this as x squared plus y squared minus 6y plus 9 equals 27. Remember, we're going to factor, all right? So remember, we take the square root of y squared, we take the square root of 9, and then we take the sign in the middle, and that becomes our perfect square trinomial in the factored form. We're going to drop down the x squared because there is nothing to complete, and then we have 27. And so one way to write this could be x squared plus y minus 3 squared equals 27. Another way to think about this is to think of it as x minus 0 squared plus y minus 3 squared equals 27. And the reason you might want to think of it that way is to identify what the center and the radius of the circle are going to be. Now the center, we can clearly see that h is going to be 0. We know that k is going to be 3. And we know that r squared is going to be 27. And that means that r, since r squared is 27, that implies that r is the square root of 27. And I'm going to keep it like that. I could certainly simplify this. Let me simplify it just to show you how you can. Because remember, 27 is 9 times 3, which would be square root of 9, square root of 3, or 3 roots of 3. But I like this better for the radius because now when we put it into our form, it becomes a little bit easier to write in the standard form for us. Okay, so both of these are correct for the radius, but square root of 27 is a little bit easier to digest. So anyway, for our center of the circle, we have the point 0, 3. Now the radius is 3 roots of 3, all right? And that's a little bit tough for us to digest. So let's plug that into our calculator as the square root of 27. And just to verify that, remember, a trick we can use is we can plug in root 27 and 3 roots of 3, and we get 5.20, okay, about, okay? So if I wanted to round that off, that would be about 5.20. And so the center of the circle is 0, 3. This is about right here. And so now what I'm going to do to plot this is I'm going to go up 5.2. All right, so that's going to be about 8.2, which might be right here. And then if we go to the right 5.2, that's going to be right here. And if we go left 5.2, that's going to be 1, 2, 3, 4, 5.2. Okay, so that's this point. And then finally, we can go down 5.2. So that's going to be 1, 2, 3, 4, 5.2. All right, and so our circle, as best as I can draw it, okay, and I'll just make the point a little bit bigger. All right, remember, this should be 8.2, so it should be like up here a little bit. So let me make that a little bit better. All right, that should be right here. And we have this point, and then down here, this point, and then we have a little bit less than 2, which is going to be this point, and then down here. Okay. Now, I think the toughest part of this is understanding what the domain and the range are going to be, all right? Because if we want exact values, here's the way we're going to think about this. We have the center point, which is 3. And so what we're doing is we're moving to the right three roots of 3, and then we're moving to the left 3 roots of 3. So our domain could be 0 minus 3 roots of 3, comma, and then this point, 0 plus 3 roots of 3. Okay, so we're just moving to the left and to the right. So this would be 0 plus 3 roots of 3. Or another way to write this would be negative 3 roots of 3, comma, positive 3 roots of 3. All right, so that's going to be our domain. Again, that's just because we're moving left 3 roots of 3 and right 3 roots of 3 from 0 at the x. And we can do the same thing with 3. Okay, so notice that we're moving, our radius, remember, is 3 roots of 3, okay, or root 27. And so for our range, we can write that as 3 minus 3 roots of 3, comma, 3 plus 3 roots of 3. All right. So we don't always get exact values. All right. But we don't always get really nice numbers, but we should probably leave things in exact if we can. And that's a way to leave it in the exact form. Right. So hopefully this is helpful for everybody that if you tried to work this through and if you weren't able to put it into this standard form, okay, which is going to be our standard form of the circle, or you aren't able to identify the radius or the center, hopefully this video helps you to be able to see how to do that. And then also, if you get not so nice numbers like this 3 roots of 3, how do you identify what the center, the domain and range are going to be? All right, so that's everything for distance, midpoint, and circles. And so this is actually the last part in chapter 1. And so now what we're going to be moving on is to chapter 2, and that's going to start with the animals of complex numbers.